rationalizing the denominator, and in this case, we're rationalizing the denominator. It has two terms. So if I have 7 over 1 plus the square root of 3, the conjugate is 5 minus the square root of 3. So that's what you would multiply by. It is a binomial, so you're going to use a binomial, and this is, by the way, is in a set of parentheses. All of these are in parentheses. You're going to use a binomial to get rid of it. So if I multiply by 5 minus the square root of 3, 5 times 5 is 25. Inner outers add the 0. Square root of 3 times square root of 3 is essentially the square root of 3 squared, or 9. You end up with 25 minus 3 in the denominator. 7 times that set of parentheses in the numerator. You'll end up with 22 in a denominator 7 times. This answer is fine. If you want to multiply the 7 through, that's fine too. Either answer will work out just fine. Depends upon what you're going to do with it. But I'd always keep this number right here out in front, as you're going to see lots of times it reduces out. It makes life nice. And then if I want to multiply it through. So here we go. 6 plus the square root of 3. I'm going to use the conjugate. And the conjugate is the square root of 6 minus the square root of 3. Square root of 6 minus the square root of 3. Now, I'm going to leave the 12 on the outside right now. Square root of 6 minus the square root of 3. And manipulate the denominator. Square root of 6 times the square root of 6 is the square root of 36. Plus square root of 3 square root of 6 is the square root of 18. Minus square root of 3 square root of 6 is minus the square root of 18. Minus square root of 3 times the square root of 3, square root of 9. I'm just foiling. Inner outers add the 0. I get 12 times the square root of 6 minus the square root of 3 over square root of 36 is 6 minus square root of 9 is 3. Twelve times the square root of 6 minus the square root of 3 over 6 minus 3 is 3. Now you notice 3 divides 12 4 times, and 3 divides 3 once, so it's killed the denominator altogether. So this becomes 4 times the square root of 6 minus the square root of 3. And reduces out. And there's no longer a radical in the denominator. And that's the goal. In college algebra and calculus, we tend to rationalize the numerator because we're manipulating formulas rather than rationalize the denominator. Here it is a binomial. So I use a binomial to kill it. This is 5 minus the square root of 7. I'm going to multiply by 5 plus the square root of 7. It's conjugate. Again, I'm going to take the square root of 3, leave it on the outside, 5 plus the square root of 7, and then FOIL the rest. 5 times 5 is 25. Inner is minus 5 square roots of 7. Outer is plus 5 square roots of 7. Last is the square root of 7 times the square root of 7, which is minus the square root of 49. So I have the square root of 3 times 5 plus the square root of 7. Inner outers add the 0, so that's what killed the radical. So it's 25 minus 7, or the square root of 3 times 5 plus the square root of 7 over 18. Perfectly good answer. Now, if you want to multiply that radical through, you can. It is using the distributive property. Square root of 3 times 5 is 5 square roots of 3, plus square root of 3 times the square root of 7, square root of 21. But I'll tell you what, I quit while I was ahead. Whether the chances are that you're going to make a mistake going from here to here. Pretty good, because you're multiplying through by a radical. So either answer is fine, depends upon what you're going to do with it.